here velocity of RQ. Velocity of RQ is equal to angular velocity of RQ into length of the link RQ. What is the length of the link RQ? 0.175 mm. Am I right? Yes. 0.175 mm. So we know the velocity of RQ by measurement as 0.32 meters per second, which means 0.32 divided by 0.175 will be the what? Angular velocity of RQ. Similarly, velocity of RS equal to angular velocity of RS into length of the link RS, that is 0.1125 in terms of meter. So now we know that similar method, velocity of RS is, according to my value, it is 0.44 divided by 0.1125. I can get velocity of, that is angular velocity of RS. So this is second equal to dash radian per second. So while calculating the values, before calculating, what you have to do is, first you have to fix the decimal point into two decimals. So in order to fix the two decimal in the calculator, that is Casio FX991MS, you can go to the mode button and press it for 5 times. 1, 2, 3, 4 and 5. You can get the display as fixed scientific normal. So you can press 1, and in that you are asked to specify how many digits or how many decimal points you need. So I am marking as 2. So now the calculator is fixed to 2 decimal points. So what I am doing is I am multiplying this, dividing this value 0.32 divided by 0.175. The obtained value is 1.83 radian per second. That is the angular velocity of RQ. Next, what I am going to do is, I am going to again calculate for the angular velocity of RS. That is 0.44 divided by 0.1125. The value is 3.91 radian per second. That is angular velocity of RS. So this is how you have to draw your velocity diagram, and through measurements you can calculate the angular velocity. In class, what we have seen, this problem is to draw about the velocity diagram. So once again I recall how to draw the velocity diagram. So velocity diagram is always perpendicular to the space diagram. So in this space diagram we have drawn according to the scale 1:2. And you know the measurements, so you have converted the measurements according to the scale value and you have constructed the space diagram. After constructing the space diagram, you need to find the velocity values. In order to find the velocity value, there is a formula. The formula is, that is the angular velocity of the particular link into length of the link. So here the angular velocity of the link PQ is given as 10 radian per second. So 10 radian per second, that is 10 into the length of the link PQ. Here in the question it is given as 62.5 mm. So what you have to do is you have to convert this millimeter into meter, which means 62.5 divided by 1000. You will obtain a value that is 0.0625. So if you multiply these values, you will obtain the velocity of the particular link PQ. So this is what we have seen. After finding this value, what we have to do is, by using the stationary, you have to construct the velocity. That is, by using the set square and the roller scale, these two components, you have to construct the velocity diagram. So first of all, what you have to do is, you have to take a perpendicular line to the link PQ. So first, you have taken the perpendicular line, and this is how you have to transform the perpendicular line. The perpendicular means 90-degree line. So this is how I have transformed the line for the link PQ. So P to Q is space diagram. So the value of this line is 0.625, which means I have taken the scale as 1 centimeter equal to 0.1 meter per second. That is 6.2 centimeter. I have constructed a line. So this is the first point. And the second line, that is at QR. So for this line again you have to take a perpendicular line, and from the end point of this line, that is from Q, you have to take a perpendicular line to QR. So you have to draw a perpendicular line by using this roller scale QR. So this is the second point. And the third point what we have done in the previous class is by taking a perpendicular line to the length RS. So you have taken this perpendicular line. So this is how we have to transform this line. Okay. So this line you have to transform it. Yes. So this is how you have to transform this line. And from the starting point of P to PS, you have to construct a perpendicular line, that is R. So this is how you have drawn the velocity diagram. So we already know about the velocity diagram. A velocity diagram will be in a triangular shape. So after obtaining the completing the diagram, you have to measure the each length. So first of all, we know this length and the velocity is calculated by manually, and these two lengths, that is QR and RS. So these two lengths you have to measure and you have to convert it to the scale and you have to write the value. So this is how you will find the velocity. After finding the velocity, you need to find the angular velocity. So in order to find the angular velocity, the formula is angular velocity will be equal to velocity divided by length of the link. So angular velocity is found out for link RQ, that is 1.83 radian per second. Similarly for RS,